All right, here we are in part 2 of the lecture on file I/O. In the previous lecture, we actually used the insertion operator to write information to a file. Right now, we'll use the extraction operator to read information from a file. All right, so like I said, we've worked with C in and C out. We've seen, in particular then, C out, we use what looks like a double greater than sign. That is called the extraction operator, right? It extracts formatted, with C in, we use the extraction operator to extract information from an input stream. So it extracts formatted input, right? And so once again, when it's used with the stream object, then it works as the extraction operator. It can also act as a bitwise operator with non-stream operations, but that's a later topic. So for us, extraction operator, we've used this double greater than sign with CN. It's been overloaded to work with arithmetic types. We've seen with CN, we could read floats, doubles, ints, unsigned ints. And so if we go out to this reference page here on the input stream class, right, this operator, the double greater than sign, has been overloaded. It can read in Boolean types, shorts, unsigned shorts. It gives you a whole list of all the arithmetic types it's been written to work with. We've not worked with stream buffers, manipulators. We don't need to worry about that at this point. What we're going to see next is this particular operation here is a reference to an input stream operator. So it's going to work with our input stream objects that we create. All right. The insertion operator, then, the double less than sign, we've used that with cout, right? That inserts formatted output into the output stream. That's been overloaded as well. We've seen with cout, right? We could write variables that were of type bool, short, unsigned. So all these arithmetic types are the same. We've been able to write that information out. We just saw in the previous example that we created an OF stream operator, and we're able to output that information to a file. So, in this particular case, right, I've got an example here of how these streams work. Let's just go ahead and write our own code now to write information from a file. So we're going to, read information from a file. Let me pop up Visual Studio here. Right, I've got the same project I did before, but now I've got an empty CPP file called readinteger.cpp. We're just going to, our purpose is we're going to read integer values from a file. Right, we're going to need to include then the file stream library. And I'm going to show what we're writing on the console terminal. So I'm going to use IOStream here as well. Let's write main. All right, so let's declare the input stream object. Right. So standard IF stream, input file stream. I'm just going to call this infile, and I'll use this method of where I declare the object, and then we're just going to say infile. We're going to open a file, open, and I'll just call this, let's just call it integers.txt. Let's open that. By default, it's going to open it in the mode of input, right, because it's an input file stream. So I'm going to use that default argument in that function. I'm going to check, and I'm going to say if not infile, or we could say if infile.fail equal true. So if not infile, right, we'll just use the error stream to error opening input file, and we'll end our program if we can't open our file, right, because we're going to want to open it to read information in. Right. Now remember, we always close a file, so before I forget, I'm going to say infile.close here when we're done working with it. And in here, then we'll try and process our information. So at this point in the program, if our file successfully opened, let's see if we can read something in and store it in an integer. So let's declare then int I value. All right, we know that if we were using cin, we'd say something like standard cin, sorry, this way, insertion operator, and we would say I value, read that in. And all right, we give the user a prompt as well. Well, we're going to replace this input stream object with the one we just created in file. And if we read this in, all right, we're going to assume it reads it in. Let's just say, let's output and say out I value. Let's print out what's stored in I value. And the new line character. All right, so here's the thing. If this file does not exist, so this is going to look locally within my project. Let me just pop open that project folder, close that. Long path to get to it. All right, this is, all right, so yeah. This project then is in a folder called File Lecture. It's the name of the solution. Then there's a project with the same name in here. You can see my project name is file_lecture. All right, so if we open that up, here's code from the previous example where we wrote this. Here's the output file it made. But my point is, in here, I have no file named integers.txt. Nothing in debug, right? That's Visual Studio folder. I didn't put anything in there. This file does not exist. It doesn't exist up here. But we would expect this to fail in opening. So let's just do a run to cursor here. All right, so you can see local variables down here. And if you can see that on your screen, in file, right, I value has nothing in it. So I'm going to hit F10. Right, which we'll check this, and notice this was true. Right, in file failed open. So this Boolean was true. And we're going to output error opening file. We're going to return 1, we're going to end. So that file did not exist. Right, and if I pop this open, you can see that that output that message. Well, that file needs to exist then. So let's just go ahead and create that. Now I could create it with Notepad. We could also likely create it with Visual Studio. So if I say file new file, and look, it gives me a whole choice of files here. The top one here under general is text file. So let me just say open. All right, now let's just type in some integer values, -13. That doesn't seem very lucky. 4, 5, 128. As long as they're space delimited, they can be on the same line. I put 2 spaces there. I can use the tab character -52. All right, so they can be on separate lines, same line. You can end it with a new line, doesn't matter. I'm going to save this file. Oh, so notice I wasn't paying attention. When I created this, it gave it a default name of textfile1.txt. Let me just save that. Oh, good. Save file as. So, file lecture in my project folder. I just want to call this integers. And it's going, you can see save type as.txt. It will append that there. Let's pop this back open here. So in this project now, I've got integers.txt, right? So it didn't save it with that textfile1.txt. So that is in the same file as my source code. So now, if we run this, right? Let's say run the cursor. If I hit F, okay, we're sitting here waiting. All right, so now if I hit F10, right? Notice that wasn't true, it skipped over that, so it should execute infile.ivalue. So now you can see that ivalue is -13. What's our first value there in the file? So when it opens a file, we have a pointer to the start of the file, and it will start reading from the beginning of the file. It will will read until it encounters end of file. In this case, we only asked it to read one value. Again, if I hit F10 here, right, we pop this open, we can see it printed out our I value. Right. And so I'm just going to hit stop debugging here. Right, so that read in one value successfully. Let's read in multiple values. All right. So there's an end of file marker, right, that we can use. So we could check to see if we read until the end of file. The expression in file.I value actually works something like a Boolean condition. Right? It's been written in a way that basically true or false is returned whenever this reads. So we'll see then when this successfully reads in a value, it'll return true. And we'll just keep reading that in. Right? So let's look at an example here of where I've changed this file. So this is very similar to what we're doing. So here I used exit failure to leave. So here I added a condition while in file, right? While that successfully reads in the I value, it's going to just print it back out. So let's modify our code to do that as well. And so we're just going to actually say while in file, I value. So while that successfully reads, because when it successfully reads, it returns true. We'll get rid of that semicolon. Let's just go ahead and print out the value that it reads. And let's go back. So we can see, we would expect to see -13, 4, 5, 128, 17, -52. Let's just go ahead and say, start without debugging here. Right, so it went through and it read all of those file values and it output them. So when this failed to read, then it stopped running our loop, right? Like we're used to. All right. Now that's all well and good as long as your file is perfect. And so we'll find that when we're working with input files, right, when somebody's created a file for us, they have to give us some idea about the type of data in the file. They have to tell us something about the file structure, but not everything's perfect, right? What happens if a non-integer character gets typed somewhere in the file? So 5a. All I did was change the input file here. We're going to go back over. We're going to say start without debugging, and we're going to pop up, and we're going to see that, well, we got -13, 4, and 5. Right. -13, 4, and 5. Right. We know cin fails. When we ask cin to read an integer and it gets a non-numeric character, it fails. Well, our file operations can do the same thing as well. So what we want to know is when we get here, we want to know, did the loop quit because end of file? And the file was reached, right, or was there some other error? So what we can do is we can check for an end of file condition. We can say if infile.eof, right, so that's a function. So if it's at the end of file, right, we will then output a message saying end of file reached, all data read. We'll assume all data has been successfully read. Else, in that case, we didn't get to the end of the file. So let's just say error, not all file data read. Okay. So let's rerun this. All right, so now you can see, right, I left that A over in that file. In this case, we did not reach the end of file, so we printed out this error message, not all file data read. Now there's not really a whole lot we can do to recover, right? We wouldn't necessarily try to go in and read this file. Well, we could try to get rid of whatever's on this particular line. We're not going to worry about that in our file processing that we do here. Right? We're going to basically work with files that have good data. We're not going to try to get into methods of trying to recover from that. We will just let the user know when there's been some sort of error. Right. All right, and if I get rid of this A now, save this, everything's in a good state, and we pop back up over here and say, well, let's start without debugging. Right, now we can see all our values were read in, and this end of file condition was true. So we printed out the message, end of file reached, all data read. Right, so that's a way for us to check when we use this to make sure this was successfully read. This could quit either because it encounters an error, in which case the fail bit is set, or it could quit because it reached the end of file. And you can do things. You could check the fail bit instead of checking for end of file here. Question is the fail bit necessarily set when we reach end of file? Right, so it's safer to check for end of file if we could say if, actually, let's just check for fail. So instead of this, let's say fail. Let's switch messages. All right, fail. All right, so this is a case, right, where everything's in our file is still good. Let's do a start without debugging. I'll rebuild it. When this pops up, notice we got the error message, not all file data read. That's telling us, and we should dig deeper into documentation, that EOF sets the file bit. So if we were to just check fail, in this case, we went through our entire file. That's not a good thing to check to know if we're at EOF. If we need to know whether or not we've gone through the entire file, right, we need to actually then check for EOF here. Right, and that. If you could hear groaning on this, my puppy seems to be rolling around while taking his nap and making little noises. So sorry about that. All right, so check for EOF if you really want to know if it's end of file. Not fail, because the fail bit is set at the end of file. All right. So just put that back to our other state. That was, I believe, everything else that I wanted to cover in this example. So all we did was we read in some integers. Now we could change data types and change our file. I suggest that you try that as well, right? Go ahead and change this to a different data type. Try reading that in. But that's one example then of how to read and work with a file. Input file.